Energy Radio, a podcast from CEM Engineering.
On this episode, we have a local guest about a local project, and without further ado, Graham Guest, welcome to the podcast.
Yeah, thanks, Matt. Thanks for having me here.
You have a great surname to be a guest on a podcast.
Yeah, I have a great surname for hotels, airports.
Right.
I mean, lots of places. It's a good one.
Do people probably crack a lot of jokes about
Yes.
that? Yeah.
Yes. And now often people think that my last name is Guess without the T. And so when I give them my last name, they look at me and they're like, Smith? Robinson?
Okay,
Yeah,
gotcha.
so get some of that too.
That's good. Well, thanks for joining us. This is a take two for you and I, but I think this is going to be good. Maybe just kind of give us a bit of your backstory. Who are you? How do you kind of come to be here today? And then we'll jump in from there.
Sure. So I work at Walker Industries. I've been there for about 21 years. And I think what brings us together today is the common interest in renewable natural gas. Of course, we just commissioned our very large project up at the site last December.
Yeah, still fresh.
Yeah, still fresh. Still working some of the bugs out, which I'm sure we'll get to.
Yeah.
So that's...
So 21 years with Walker. Were you doing something else before that?
Yeah, I was in the heavy municipal infrastructure space. I built water towers for 15 years.
Really? Okay.
Elevated water towers. That was my gig.
Okay, my 4-year-old has become fascinated as we drive around about water towers just in the last week.
Oh.
And so he couldn't figure out the one in Thorold because it's the short one, right? It didn't look like. He's like, "What's that, Dad? It's a water tower." No, it's not a water tower, Dad. It is a water tower. So, anyways, okay, that's fun.
Yeah.
So then you join Walker. Tell us about what Walker does.
Yeah. So Walker Industries is a 6th-generation family-run business. Gen 5 is Jordy Walker, who's the current president and CEO.
Okay.
And so that company's been active in Niagara Falls for 136 years on the same site. Primarily started off as an aggregate producer, so we still have limestone quarries on site that we're extracting rock from.
Yeah.
In the early 1970s, Norris Walker and John Walker, who were the previous generation owners, decided to get into the environmental space.
Okay.
And so they opened the first landfill in 1974.
Okay.
And that operated until the mid-'80s. And then we opened what we call the East Landfill in the mid-'80s, which is really our first foray into kind of solid non-hazardous waste. The other site was more of an industrial fill.
Okay.
And so now we have really what's the 3rd largest landfill in the province next to Waste Management and Progressive Sites.
Wow.
So take about 1.1 million tons a year into that site.
Okay.
And we are extracting approximately 7,000 SCFM of landfill gas from it and do a number of utilization projects with it, including RNG.
Wow. So is it a natural transition, like you pull the limestone out of the ground and then you have a big hole and then it's perfectly suited for a land? Like, is it that simple? Or
It's not quite that simple, although that is how it kind of transpired at Walker. Landfills are extremely complicated.
Yes.
But the hydraulic conditions at that site are really favorable. There's kind of an inward gradient, so the groundwater is always pushing up into the bottom of the quarry. And so when you put the double generic liner that we're required to put into the bottom of the landfill to separate waste from the groundwater, you almost have this natural kind of added benefit of having the groundwater wanting to push upwards into the landfill. So there's almost 0% chance that leachate or contaminated water could escape through the liner system, because the liner system is engineered to last for 300 years.
Right.
But on top of that, you've got this upward pressure from below that helps keep the landfill leachate in check, if something terrible were to happen. And not every site is like that.
That's specific to Niagara.
None of our other quarry sites are like that. And so this is just it just happens to be the conditions at that site.
Wow,
up
cool.
in Niagara Falls.
So when you joined in the early 2000s, then 21 years ago, do you come in? So it's an operating landfill by then. Like what do you kind of come into?
So I came in to do largely project management. At the time, we were really into municipal infrastructure. So we owned a group called Integrated Municipal Services.
Okay.
My first project was to build the Blue Box Recycling Center that's on just off of Montrose Road there for the region of Niagara.
Oh, okay.
So that was my very first project with Walker. They had bid on the project and were successful, but didn't really have a PM for it.
Yes.
So I came in and we ended up building that, and then we just went on and started building other projects. That same in that kind of same cycle, probably those first 5 or 6 years, we ended up constructing the Niagara biosolids facility, which is across the street from our head office, as well as our composting site, all anchored by municipal contracts, which is really the model that Walker used to deliver projects like that. We would bid on a long-term disposal or treatment contract. Then we would build the infrastructure to support that contract.
And you were always building infrastructure that Walker owned, or you were building it for other people?
Always building infrastructure that Walker owns and operates. In fact, I always have to thank Walker. If they didn't operate businesses, I wouldn't have a job. I wouldn't get to build anything. So that's largely been kind of the deal at Walker, is that I am the constructor of all the infrastructure. When I say I really mean the whole technical services group.
And then when it's up and running, you turn it over to ops?
When it's up and running, then it gets turned over to operations, and it's a little different than a traditional design, bid, build, warranty, and exit the scene, never to be seen again. I sit right beside the guy that operates the facility, and so there's a lifelong warranty associated with that facility.
And it's described as Graham's reputation.
That's right. And so we drag the operators in early on, and we're often able to make decisions around the life cycle of the project that you wouldn't make if you were just building it for somebody, They'd be like, hey, I want it at the cheapest price and the quickest timetable. Obviously, if you're operating it for 20 years, you can make decisions that are not based on necessarily a return on the construction project.
I love
You're
it.
thinking a little bit more longer term.
And is your tech services group getting involved in, like, obviously when you don't actually build the project unless you get the contract, but you need to do some kind of development in order to bid it, I would imagine, right? Like, and you guys are getting involved in that early stage as well?
Yeah, we do a lot of pre-project development work. In fact, there's 3 or 4 of us that's kind of the primary job, is to go and evaluate projects, go and evaluate opportunities. And now, since we really stopped bidding on external work, and we have a number of municipal contracts that anchor all of the infrastructure up at the campus, but we used to deliver those services kind of outside the region in other areas, and we don't do that as much anymore. It really is a function of people that probably aren't as well qualified when it's a publicly tendered job. It's really low bid. If you can get a bond, you can get the job. So unfortunately, what we see is people that are trying to keep their forces busy. Maybe it's not their area of expertise. They're moving in to do work that they're just bidding low, so that they can get it and stay busy, and it inevitably goes kind of sideways, which is not great for anybody. Unfortunately, that's the publicly tendered world out there now.
Yeah, it's an unfortunate reality. So let's go back then to landfill gas. So you said the early 70s they built the first landfill, but it's kind of the second one that is kind of, second, and are there 3 built it out in phases?
Yeah, that's right. So we've got the active landfill is what we call the South Landfill. That one opened in 2009. And so the East Landfill really opened in 1983 and was active until 2009. And so we have approximately 160 wells in the East Landfill and another 140 in the South. The gas curve is declining in the East. It's been closed, and we're not taking protrusible waste into that site, and haven't for a number of years.
You got to say that word again, because I have not heard
protrusible.
That. Protrusible, yeah.
Stuff that'll smell and break down.
Smell and break down.
And usually the breaking down is the cause of the odors. Non-protrusible waste is... Is
it analogous to organic, or not necessarily?
I suppose it is. And people always think of organics, certainly in today's day and age, of things like food scraps, and manure, like those real, the obvious ones. But clothing, linen, wood, couches, things like that. When you throw them in a landfill, and they decompose under anaerobic conditions, they will generate methane.
And is it because of the long time horizon? Like, if you put them in, by contrast, a anaerobic digester, purpose built, that stuff won't break down, or it won't break down. Like, is it because of the length of time or the pressure it's under, or what causes it to break down?
Yeah, so I mean, it's a natural. The breakdown happens naturally.
Yes.
And if you threw that same stick of lumber, into the forest, that stick of lumber would break down. I don't think you'd want to throw that stick of lumber in your digester.
Right.
Obviously.
Yeah.
So obviously, the majority of the digesters that we're seeing now that are purpose built are specifically for SSO, right? Source separated organics, clean food streams, leftover industrial food processing wastes. So those digesters are well suited for that.
Right.
You're getting all the gas, like all of the gas.
Yeah, right.
And you're getting none of the atmosphere, which is a challenge for landfills because when we put them under vacuum, you're also pulling in nitrogen and oxygen.
Right.
So you get the...
and you do that because you don't want the smell to escape, right?
That's right.
Yeah,
that's right. So we have certain collection efficiency targets and mandates from the government that require us to really build out a curve that's based on a couple of assumptions, but relatively well proven assumptions now, as the landfill gas industry is pretty mature, and they've been developed the curves for a long time. And so things like the gas generation potential, which is one of the variables that goes into the curve, based on the constituents of the waste stream. If you have a heavier food supply, you're going to have more gas generation. If you get more industrial waste streams that don't have the organic compounds or the organic fractions in them, then that gas generation curve goes down, and the overall curve will drop a little bit.
Okay, got it. Okay. So in '83, you build the East landfill.
Yep.
And then walk me through how you go about, like, at what point in the life of a landfill do you start, putting in collection systems and actually getting the landfill gas? How does that all work?
Yeah, so Walker was one of the early adopters of landfill gas collection, and we did it because we had odor problems.
Okay.
Landfill gas, as a byproduct of creating methane, you also create hydrogen sulfide.
Yeah.
And so, people always say, "Oh, I can smell landfill gas." Yeah, it's the landfill gas is the carrier molecule of the hydrogen sulfide, which is really what you're smelling.
Right.
But yeah, so in the I would say 1999, I think, was the year that we first realized we had an odor issue coming from the east.
Okay.
And we connected with a small company called Comcor Environmental out of Cambridge. And those guys had some experience in the U.S. running landfill gas collection systems. They came to Walker and they said, yeah, we can put in some pipes, put in a little blower, and help you kind of contain some of the gas.
Okay, so from 83 to 99, so you're just putting it in, covering it, and that's it?
And that's it.
Okay.
And there were no regulations that required you.
Okay.
There was no...
Got it.
The regulations weren't developed enough at the time to require landfills to have landfill gas collection systems. Of course, they do now.
Yes.
You can't get an ECA without a fully developed landfill gas capture and collection system. And so, so for all those years, and for every landfill really in Canada at the time, the emissions were unabated.
Got it. Okay.
So then we got a little bit smarter, started having some odor problems, and having, being a good corporate citizen, we wanted to try and do something about that.
Yeah.
So we started capturing that gas, and we were just burning it in a flare.
Okay.
And then we realized we could generate credits. And for a decade, Walker was the largest carbon trader in Canada. In fact, if you flew on Air Canada and checked the box that said, I'd like to offset my flight, you would be purchasing credits that came from Walker. We sold them to Air Canada, and Air Canada sold them to you.
Wow.
Yeah.
Okay. And you could sell them as credits because
there was no regulation requiring us to capture the landfill gas.
I see. Okay.
So that's a voluntary credit. So we were playing in the voluntary space, just like you're under no obligation to offset your flight.
Yes, right.
That's just it's an add-on service that you would select if you so desired.
Okay.
And so because we were capturing methane and destroying it prior to there being a regulated requirement to do so, we were able to sell those credits into the voluntary space, and we were given credit for the credits.
Yeah, got it.
We can't do that now with the landfill gas, so we don't generate emission reduction credits from the gas we capture from either of the landfills, and that regulation sunsetted in June of 2016.
Okay.
So even though we continue to capture landfill gas from the East landfill with the same system that we installed early days, we no longer generate voluntary credits because they're no longer eligible.
So does the sunset of that program, does that start to get the wheels going about what else to do with, like, how do you go from capturing it and burning it in a flare to, I mean, you've really got kind of two projects that you've built out from what I know, maybe more, but walk us through kind of that, the brainchild there and how you get through that.
So of course, when you're, you've got the flare on site and you're looking at you're just looking at the flame and you're like, wow, that seems like such a waste. There must be something more we can do with that.
Yeah.
And so in 2000 and I started in 2003 at Walker. And I'm going to say in 2001, we made a connection literally and figuratively with the Abitibi paper mill.
Okay. Yes. Right. I forgot this. Yeah.
Yeah. And so the Abitibi had two natural gas fired boilers, which produced the heat that made steam load for the plant. And so we decided that we could install a dedicated pipeline between the landfill and the mill, and we would send them landfill gas.
Okay.
So we engaged with Enbridge, and they built us the pipeline.
Oh, okay.
And so Enbridge owns that pipeline.
Okay.
It's a bilateral pipeline. There's no other thing in that pipeline other than landfill gas. And that project was so successful, we put in a second line.
Okay.
And at one point in time, we were displacing 95% of the natural gas that the mill was consuming in their boilers with landfill gas.
That's awesome.
Yeah.
Were you doing any treatment before you put it in the pipe?
Only drying it,
Only
so that we
drying
could
it, okay.
compress it.
Yeah, okay,
So it went with sulfur.
Okay.
So you didn't have to take the sulfur out.
Okay.
And you didn't have to take the siloxanes out
Yeah.
because it was just being consumed in a boiler. Very tolerant appliance.
Yeah.
And lots of industrial boilers are super tolerant for kind of,
And what level
dirty
of
gas.
H2S do you get?
Like sub 1,000 ppm.
Okay. Yeah.
So you get obviously much higher to digester.
Yeah.
Landfill, I would say, averages. The East landfill actually averages around 500 ppm.
Okay.
A
Wow.
little higher in the south with some active waste.
Right.
But that
Okay.
waste is mature in the east, and so the sulfur content's kind of dropping off there.
Got
now.
it. Okay.
Yeah. So we started off with this direct use project, and then the mill shuttered
Yeah.
in 2016. And their consumption was going down. They actually went from one pulper to from two pulpers just down to one, and so their load was coming off. And then eventually, of course, they shuttered the mill, and that was the end of that project. Meanwhile, we had invested, because we had more gas than they could consume, we entered into the electrical generation space.
Oh, okay.
And so when the first RESOP programs came out from the OPA, which is now the IASO, of course, they were looking for renewable generation, and so we started to get into that market. And we currently have about 15 megawatts of landfill gas.
15, 1.5?
Yeah, 1.5.
Wow. Okay.
Under contract with the
Really?
province.
Okay.
Yeah, we've got a 5 megawatt facility in Mississauga.
Okay.
6 megawatts in Ottawa, and
Okay.
4 megawatts down at the Moose Creek landfill that's owned by GFL now.
Okay. So these are most of this time we've been talking about the site here in Niagara, but these are RESOP or I guess FIT contracts now at other facilities. That you own or you operate?
That we have the landfill gas rights to.
Okay, got it. Okay.
So we would often get involved with municipal owners or private owners
Yeah.
and do landfill gas collection system design, installation, and operations.
Okay.
And that's kind of how the landfill gas business grew. And I mentioned Comcor early on, and we started a formal partnership with Comcor called Integrated Gas Recovery Services. That partnership started in, I'm going to say 2003-ish, 2002 maybe, just when I was kind of coming onto the scene with Walker. So that partnership's been going for 21 plus years.
Wow.
And we've done a number of projects all over the province. Some are now over, and although we still have many that are currently operating.
Yeah. So you've got those FIT contracts up and running, and then what happens here in Niagara when Abitibi goes away? You have some that goes into FIT contracts. It's still running.
Yeah, we have a 1 megawatt generator that supplies power to the grid through a FIT contract.
Yeah.
And then, of course, with the mill shuttering, we had surplus gas, and we were continuing to look for opportunities to do something with that gas. Ultimately, we ended up partnering with General Motors.
Right.
And so in 19 in 2019, 2018, we started to really tie a bow around the idea that we could get landfill gas down to General Motors and do it economically, such that it made sense for both Walker and for GM. And so we started to develop that project. We have a 3.5 kilometer bilateral pipeline now that goes down to Abitibi to General Motors.
And did Enbridge build that one as well?
No, we built that one.
No way. Wow.
Yeah,
Okay.
we built that one.
Okay.
So Enbridge is not involved in that project in any way, shape, or form.
Yeah.
And they didn't need to be. We only crossed through 3 pieces of property: Walker's property, General Motors property, and the St. Lawrence Seaway.
Oh yeah.
So we had to go
just the federal government.
Just the federal government. Yeah. And that permit took 3 years. By the way, 3 years to get that permit. And we directionally.
And it's probably not a big piece of property.
No, it's a very small strip, and we directionally bored underneath. There was only one surface disturbance on the St. Lawrence property.
Wow. 3 years.
3 years to get a permit. It was insane.
That's crazy.
Yeah.
So you're sending gas down, and what are they doing with it there?
So they make power as well. There's actually it's set for a trigen. They're currently only doing cogen. Okay. So they do 6.4 megawatts of electricity. 8 megawatts of heat. Yeah. And then they're set up to do adsorption cooling. So they want to turn it into a trigen facility.
Oh, that's awesome.
Yeah, literally.
Okay. Yeah. and so yeah, I get it now. And so how much of your gas do you sell to them then? You sell it as a commodity.
Yeah,
to
we
them?
sell it. Yeah, we sell it as a fuel. Yeah. And the real win for them, of course, is it obviously lowers their greenhouse gas emissions. And in fact, it is now the lowest. It has the lowest carbon footprint of any engine and transmission plant globally.
Wow, really?
For GM, and it makes that plant extremely competitive.
Yeah, great.
Which is a great story for St. Catharines in terms of job retention. And since we installed that facility, since the electrical facility was installed and we hooked it up to the pipeline, I think GM will tell you there's been like north of $100 million of investment into that plant.
Really? So unrelated to the cogen?
Unrelated to the cogen,
but because of it?
In terms of
or in part
upgrading the line and getting retooling.
Wow.
Yeah, so lots of investment from the mothership because that plant is so competitive, it's so green, and makes good sense for them.
So they buy it from you as a fuel and they buy the associated environmental benefits as well, is that right?
Yeah, in fact, the IESO, who helped fund the project through some incentive programs they had, because the province is looking to increase electrical consumption, but not necessarily electrical generation. Right. And so for small facilities like General Motors, it's easier for them to build a generating asset than it is for the province to build a larger asset and then get a dedicated customer. And the ISO knows this and the province knows this. And so the Process Systems Upgrade Incentive Program, and I think it's had a couple of different names over the years, it's really that program from the ISO that helps support bespoke generation builds on an customer by customer basis. So General Motors was able to apply to that program. They received some funding from which they were able to purchase the 4 engines that are there. Yeah. We partnered up as a fuel supplier. Yeah. And so what we're doing is really lowering their grid demand. Yeah. And it helps them manage their global adjustment. Right. And the project is tremendously successful for them. It allows them to base load the plant on peak days. Yeah. So they can kind of idle that facility without having to turn the lights off when peak days come. And then they can come back online. Awesome. And so they're really helping themselves get off the GA, and that was the driver for that.
That's great, cool. And then that brings us kind of, I think, chronologically to the latest project, right?
Correct.
And there's like any RNG project, there's a whole bunch of backstory in the development. To the extent that you can you kind of walk us through the highlights of that process?
Yeah, for sure. Again, surplus gas. We're continuing to add waste to that landfill, and so the gas curve continues to climb. We have fixed consumption to General Motors. We have fixed consumption by the 1 megawatt electrical generator that we have through the RESOP contract. Right. And so, always trying to find ways to do more with that resource. I mean, I would tell you that's, it should be everybody's goal, but it's certainly on paper, on the wall at Walker. That is,
Right.
we're the stewards of a number of resources, and we're always trying to find something to do with those resources. And
that.
landfill gas is an obvious one. We've had successful utilization projects in the past, and so you just need the stars to line up on these things, as you know, right? And so through our experience with General Motors and the process system upgrade incentive that allowed them to put some engines in their facility, we decided to do that as well, because now that we were sending and compressing gas down to GM, we had a much larger load, and now it's a stable load.
Yeah.
So we put in our own generator running on landfill gas that now offsets the full load of all the compressors that we send gas.
I've been to the site, but I
GM.
didn't put two and two together on that. Okay, that's cool. I love that.
And then, of course, we continued to have surplus gas, and now we're like, okay, RNG. RNG was always kind of out there. And we've been aware of it for years. In fact, my first visit to an RNG facility was 2014.
Wow.
Went down to Dallas and saw a Morrow Renewables site. And talked with those guys, and we kind of came away from that trip thinking, we can do this. Like we can do this. Of course, the industry was pretty young at that moment in time. And very young in Canada. Of course, young in the U.S. and they have the scale and they have the scale of landfills to do it. Some of those landfills in the U.S. are licensed for hundreds of millions of tons of waste. There, it's mind-numbing how big they are. Relative to ours.
Sure.
But on an economically viable scale, we always thought we would have enough gas to do a project, and then, like all developers, you wait till the cost of technology comes down. You wait till the market is got enough demand to get the price that you need, and then you need, of course, a whole suite of other things to fall in line. Not the least of which is a willing off-taker.
And you got to get lucky a couple times.
And the regulations, and you got to, sometimes you'd rather be lucky than good, for sure.
Yeah.
So we started looking really diligently at what a project would look like there, building out the financial model, which is, I would say, almost always where you start. And the challenge when it's your first one is that there's a bunch of assumptions in there that you're, I call it unconscious incompetence. You don't know what you don't know. I mean, you're going through the list, and for sure you're going to get some of it wrong. You just don't know what pieces are going to be bad.
And the reality, I often say to people, the reality is if you did know everything at the outset, you probably wouldn't do the project.
That's right.
So you kind of need that phenomenon to actually make stuff happen, because if you knew it all, you'd be scared, into submission. You're like, it's too risky.
It's too risky,
Yeah.
So you're... That's right. Your assumptions help de-risk the model a little bit. You're like, that's going to work just fine.
So what was kind of the first, so you're looking at the financial model, what was kind of the first shoe to drop where you're like, this is real, this is going to happen?
Yeah, the first shoe to drop was really when Fortis, BC, which is the large gas utility in British Columbia, when they started procuring large quantities of renewable gas from all kinds of people. And the regulator gave them the authority to do that. We had built out the financial model. We kind of had a good, finger on our pulse of equipment costs and lead times. We kind of knew what the market was. We knew where the value was, but what we didn't have was someone who was willing to anchor that project with a long-term off-taking agreement. We, of course, had been in conversations with Fortis, and they said, they wrote the contract that had the condition precedent. That condition precedent flowed through every contract for all of the facility. And so they said, if we get approval, we'll buy the gas at this price. And then our contract with the supplier said, if we get approval from Fortis or from the regulator so that Fortis can buy the gas, and then they execute on our purchase agreement, then we'll execute on a purchase agreement with you. And so all the dominoes really started with the off-taking agreement.
And so when you first start to talk to them and you first start to look at that contract, that was before they had the regulatory approval to buy?
That was before they had the regulatory approval to do that. We had been looking at the U.S. market, which was super hot, so the RIN market. So the state, the federal program, the Renewable Fuel Standard, as well as the Low Carbon Fuel Standard in California, which is now, as you know, starting to grow in popularity amongst various states. So there was always a bit of a market there. We weren't sure if we wanted to transact in that market because what we were having a hard time finding in the U.S. was a long-term deal. People will take gas for 5 years, maybe even 10 years. But at the time, we were struggling to find a 20-year offtake agreement.
And coming back to the first part of the conversation, like, is it right that was a pretty big deal for Walker because most of the history was these long-term contracts with like that? The business was built on these long-term.
The business is built on long-term contracts that stabilize the financial risk.
Yeah.
And so, using that model, and Walker is a very conservative company, and I would say that, we're into Generation 6 and we've been going for 136 years.
Yeah.
I would say maybe that's a good thing.
Yeah.
And so, having the luxury of what we call the long view at Walker, and by the long view we mean intergenerational, not 20 years. We think kind of 50 years is this time horizon for some things. It just lets you make different decisions than you might make if you only had 20 years to make that decision. So, as you noted, the history and the legacy of Walker was build complicated infrastructure that you can own and operate for 20 years, anchored with a credit-worthy partner on the other side of that table, right? Okay. So getting a utility-grade entity to enter into a long-term off-taking agreement with just felt right. And really suited the Walker model. And so that was really it. And so that's we found that stability ultimately
with Fortis.
With Fortis.
Yeah. Okay.
They don't take all the gas from that facility.
Okay.
But they do anchor it in terms of being the main off-taker from that facility.
And then somewhere along the way, so we talk about Fortis and BC as the buyer, but somewhere Enbridge also has a role.
Yeah, that's right. So Enbridge came to the table. Of course, you need a pipeline connection. Everything needs to be connected to the grid. Enbridge was offering a number of services kind of at that time because the market was really starting to move, I would say. It was becoming more mature in the U.S., which gave Canadian developers, I would say, more confidence about how to transact on projects like that. A little less risk on the technology, a little more, I would say, agreement within industry about how to do landfill projects. Hey, you need one of these, you need one of those.
Right.
So some of that stuff the body of knowledge was getting a little bit better. Enbridge wanted to get into that space. We needed help connecting, we needed an injection station, and then of course you need the connection to the nearest pipeline. And one of the problems with a lot of projects, as you likely know, is grid connectivity or isolation, right? That can be a big hurdle. And at $1 million+ a kilometer of pipeline, smaller scale projects can be really challenged to get into the grid.
Right.
And then you get into virtual pipelines and stuff. But for us, we were about 3 kilometers away from a high pressure grid. The demise of the mill, interestingly enough, actually took one of the largest consumers of natural gas away from the grid. And so as the Thorold, Niagara Falls area has, I would say, de-industrialized over the last 20 years, those large consumers of gas have had this kind of counter effect on demand. And so we couldn't just get into the local network. We actually have to ship our gas outside of the region in order to have it consumed, because in the middle of the summer, when people just are barbecuing and that's the only load, so to speak, there's only so many steaks you can cook with landfill gas, and we could cook them all and then some.
Okay.
So we needed a kind of a bigger pipe and a higher pressure network to get into. And so Enbridge got involved with us at that point in time, and our partners in the project with us. So it's been great to dealing with them. It kind of helps to have friends on the utility side.
For sure.
You need their cooperation, and they're remarkably good at some technical stuff. Quite honestly, they got a lot of resources. They're good at risk management, and they think about stuff that maybe you don't think about. And so it's nice to
that's cool.
Fill the bucket a little bit.
So then maybe describe briefly the project in terms of size and kind of what are the major, building blocks technically of the project.
Sure. So our project consumes about 4,000 SCFM of landfill gas, which is around 50%. And the output of that facility is just shy of 1 million gigajoules a year, about
annually.
950. So we always scoped it for that size. We do produce more gas than that, and ultimately the ultimate gas curve at the landfill will be a little bit more than what all of our utilization projects can consume all at once. So we will have some surplus gas, but not for long enough that it made it economically viable to make the facility bigger.
Got it.
Because the gas curve peaks and then it'll drop off.
Right.
And so for a short number of years, we'll just be flaring gas unless we can find some other smaller utilization project. So it's 4,000 SCFM, million GJs, and it has, I would say, the whole suite of technology.
Okay.
We use static carbon vessels to take out the hydrogen sulfide.
Okay.
Because the levels are low enough that you don't need
something
any more potent than that. We use heat exchangers and chillers for dehydration.
Yeah.
We have then membrane separation to deal with so we have a little polishing vessel up front that deals with VOCs and siloxanes. So it's a pressure swing absorption vessel on the front side of the membranes.
Okay.
The membranes split the methane from the CO2.
Yeah.
Then we have another pressure swing absorption system that deals with the nitrogen.
Okay.
And finally a deoxygenating catalyst on the back end to deal with the trace O2 that's left in the gas.
Okay.
So, 4 or 5 different kind of systems, all to deal with specific components of the
compression, to boost the pressure, up and down as the process needs, and then you have probably some sales gas compressors to get it in the pipe.
That's right. So we have 2 feed gas compressors and then 2 sales gas compressors.
Okay.
And almost kind of twin everything, but not for redundancy, but more for variable flow rates.
Okay.
So, and I suppose somewhat redundancy. If one of our compressors goes down, the whole facility isn't down. We can still process half the flow.
Yeah, okay.
Which is nice, but we only have one blower. So if the main blower goes down, so we don't have 2 of everything. And if you don't have 2 of everything, you really don't have redundancy. We have partial redundancy.
Yeah, okay. So then, what's the schedule of, like, you said December of last year, fully commissioned? So we were the smartest. We were absolutely the smartest developer. We signed a contract just before COVID hit. Oh yeah, okay.
Which was brilliant. The shoe dropped in February of 2019 is when the Public Utility Commission for British Columbia passed the legislation or approved the application of Fortis to purchase renewable natural gas from areas outside of the provincial jurisdiction, of their provincial kind of boundary. And so with the signing of that, or with the acceptance of that contract, then the development dominoes start to fall. By the time we enter into a purchase agreement for equipment, you're negotiating now, right down, you're doing detailed engineering work. Which takes a lot longer than you think, by the way. I mean, you're the expert in detailed engineering.
That's what my team tells me all the time.
And so it always takes longer than you think. And as the purchaser of those services, what the engineers will tell you, so the client never responds quickly enough, right? We have 2 weeks for turnaround. That's never enough. Or then you think you can compress the schedule, and you're like, we'll just leave a week. No, don't do that.
No.
So that, of course, took us some time. And then by the time we actually ordered the equipment, it was literally December of 2020.
Okay.
And so right in the middle of the pandemic, and really at the front end of the global supply chain constraints. So we hadn't seen up until that moment.
Because it didn't really hit right away.
It didn't really hit right away, right? There was this lag from all, like, the factories, they had to shut down because their workers were sick. And then people were working from home and productivity was down. But it took a while for that to kind of manifest itself into what we now just call, COVID supply chain constraints. And of course, right when we were scheduled to have certain modules of the equipment arrive on site, people were like, hey, we can't deliver your skid because this one small part is not available and we don't know when it's going to happen. So we really did, I would say the project's a year late. A whole year. It suffered a number of reasons, but largely COVID-related delays probably put that project a full year behind schedule.
Wow.
And in some cases, we literally bought parts off of eBay for 7 times what the vendor was going to sell. So we had a purchase order for like $1,000 IO board. We bought them off of eBay
Right.
for $7,000.
Yeah.
And then when ours came in, we sold the new ones on eBay.
That's awesome.
Yeah, so that's-
controls were one of the big things in the supply chain was everything controls related.
Everything
Like
controls.
Allen Bradley stuff was just crazy.
Yeah, we thought, hey, we'll just call Allen Bradley and let them know how much we need those parts.
Right,
And they told us they had 400,000 customers in front of us. 400,000 orders in front of ours.
Yeah.
So
That's wild.
that's when the eBay search began. You have to find creative ways to get these things done.
So as you're doing the project and now kind of past it because it's operating, aside from don't buy equipment in the middle of a pandemic. I mean, what else? What are the other lessons learned or kind of warnings for others to avoid on future projects?
Yeah, it's a great question. So I would say that the partnerships that you have with people that are helping you put the project together are super important. And so, and I'm not just talking about partnerships with your foundation contractor, but like every trade that's at the site really has to be invested in the project.
Yeah.
It has, everyone has to make money, so there has to be that baseline understanding, but you have to find ways to help each other and make good project decisions. And oftentimes you find that the individual actors are acting in their best interest, which is not necessarily in the best interest of the project.
Right.
And so you have to start these conversations early days with the people that you're going to bring in to help put these projects together. So I would say teaming is kind of a thing that I would like to do more of, and I think we could have done better. There's definitely areas to do better
Specifically with on-site installation trade contractors?
Yeah, and maybe more so in our case, the equipment vendor.
Okay.
We really struggled with our equipment vendor. They were pulling in their direction, we were pulling in ours, and the project ultimately ended up suffering for it. And when you cast back, and everyone's got 20/20 hindsight.
Yeah, of course.
You're like, we should have made a different decision at that moment in time, or we could have said yes, or we could have held firm. I mean, lots of learnings, and you don't know. It's your first one.
Right.
Again, you don't know what you don't know. So I would say, pick your technology partner well. Make sure that they do come with a deep portfolio of projects that they can point to and say, here's a problem we experienced and here's the solution we developed to get through it that could work for you.
Right.
Here's here's a different problem on a different job, because every job has different problems, even if it's all the same equipment.
Right.
But what you'd want from a vendor, and what I think I would definitely be looking for going forward, is to make sure that depth of experience exists, and that you're not kind of doing your first project while someone else is doing their first project.
And I think we certainly see it. You probably have too. Like, because the RNG market is growing rapidly and is still in some ways relatively new.
Yeah.
That phenomenon of folks who don't have that deep reference base, it's more prevalent, right? If I contrast that with our work in the power generation industry, where we've been generating power for 100 years, you don't really get that as much, right?
That's right.
Those who don't have the references are no longer around, and those who do are still around, right?
Yeah.
Whereas in these newer markets, and I think hydrogen is going to be like this too.
Absolutely.
Is you got to show me, can I go to 3 or 5 sites over a period of 2 or 3 days and talk to the operators and see where you've actually made this work, right?
Yeah.
That's really wise. What about on the permitting side? Was there any kind of lessons learned or challenges or difficulties on the permitting side?
Aside from the 3-year permit story that we talked
Right.
about earlier on the General Motors pipeline project, Walker has an entire department, and all we do is permits. We are a permit intensive business.
Yes.
The landfill's intensive. The quarry is intensive. Many of the businesses that we operate require a variety of approvals, and so we have a whole team.
Yeah.
And that's all they do.
Yeah.
So I would say for us, permitting was very de-risked and
cool.
very understood. We fully understand how to add equipment to our ECAs.
That's all that was required was just modification.
Modification.
Yeah, nice.
Now at the site, we of course operate a number of businesses at that site, and we have a whole site ECA.
Okay.
So when we bolt on operations, we have to think about what's the cumulative impact to some of our core businesses, and so a good example is noise. We generate a lot of noise at the site.
Right.
We have crushing operations. When you're crushing limestone, it's noisy. And we have certain thresholds of noise that are baked into our ECA. And when we add on rotating equipment like compressors, some of that stuff can get noisy as well. So we thought deeply about, hey, the math says the pipe could be 4 inches, but if you make it 6, it won't be as loud because when those high pressures move through those pipes, they whine or they squeal.
Yeah.
And so we thought maybe more about that than maybe some other people would think about. And we just that's a cost that we're gonna, back to that. Hey, we got to operate this thing.
Right.
And we got to be, compliant with all of the requirements.
Yeah.
So that was one of those decisions where we just said, let's spend that money. That's a good use of capital for us.
That's cool.
So the permitting for us was less, I would say, risky and certainly less intimidating.
Yeah. And what about, because you had the 20-year contract, it was self-financed, the project? I mean, between you guys and Enbridge, the financing piece, putting that together, that was pretty straightforward as well.
Yeah, absolutely. So having done big projects, whether that's the landfill itself, which is a very capital-intensive project, as well as standalone projects like a biosolids facility or a composting facility. The finance team at Walker and of course our partners at Comcor and Enbridge, pretty good base of understanding on what to look for and how to manage those models.
Right.
And our models get better over time. You never get it right the first time. And even though I've built 10 or more kind of tens of millions of dollars in scale facilities, the model is ever evolving.
Right.
You're adding little layers in there, and sometimes you can go too far. The KISS acronym really can come into play there. You do need to keep it somewhat simple.
Right.
Just as long as you're aware that there are little influencing factors. But we think the financial model is probably the piece we spend the most time on.
Yeah, for sure. And what about, so you build the thing, you got the trade contractors, you finally get the equipment there. Commissioning is always something that I think I always talk to our team about. We got to be thinking about that earlier on because it's so
way
critical.
Earlier.
Yeah, I mean, some things that come out in commissioning that you guys learned, or challenges, or.
Yep. So one of the things that we learned is that we needed more transparency, and you may or may not have seen this before on some of your projects. We needed a little more transparency between the contract that we had with the various vendors, all of them, including the equipment vendor, and the contract that those people have with the people that are supporting them. Because you don't know what they're asking for. And at the end, you have no contractual relationship with the third parties. So you say, hey, I want a car that's got that goes 150 miles an hour, and what you think you're buying is the Chevy Big Block, and what you ultimately get is, somebody went to a junkyard and pulled out, a four-banger and bored it out, and for a moment it'll go 150, right? Like you really need to be able to see deeper through the food chain, I would say, of contracts. So that was maybe a lesson learned that I would want to do again.
Give us an example of how that manifested?
I will.
Yeah, okay.
It showed up in commissioning.
Yeah, okay.
So what we found is that the equipment vendor had not signed a contract with some of the equipment suppliers to come and commission their equipment.
Oh, okay.
So even though our contract was, hey, supply this package of equipment to us, we'll install it, but then you'll come to the site and you'll bring your guy and you'll commission it.
Yeah.
And what we discovered is that they were waiting to execute on those contracts until we were a little further down the road. And then by the time we got there, it was too late, and we ended up engaging some of those vendors ourselves.
Oh, really?
Yeah.
Okay. Wow.
And so, it was probably to do with the fact that it wasn't very well scoped.
Yeah.
And when you talk about getting that done earlier, I would say absolutely. In the development cycle, our next project, we will have a commissioning document, and we do now because we've gone through the pain.
Yeah.
But we've got a good reference now from a document perspective that we can say, this is what we mean by commissioning. This is what man hours look like.
Yeah.
This is what this is when the clock starts ticking. This is how we want remote support. And so, as I said earlier, if you're pulling together for the project, then when you enter into those agreements, you're like, yeah, when you said you give us 2 days of support, I mean like 16 hours on site. I don't mean you fly in the morning, arrive at 2, and then leave the next day at 11 because you need to be home at the end of day 2. That's not what I meant by 2 days of support. I really meant like 2 full shifts on the site. Right. Right. That's kind of what I meant. So just little stupid stuff like that. And if you make that clear up front, then I think helps people.
Totally. And particularly, a facility like this, there's so many different operating cases and so many different, it's one thing to commission it so that it, you actually prove out, full output, but there's so many different ways and you have to test and maybe that's not commissioning, maybe that's testing or some kind of validation, but it's all part of that, right? And you have to think about all those different scenarios and, we're not perfect at it either, but we're trying to get better at defining that early on because then it provides a guide for engineering and construction. That's the goal we're working towards, right? We're going to have to commission it this way. Okay, well, that may shape some changes in design and construction so that you're ready for that.
And you need clear milestones that are performance-based milestones so that the people that are participating in the project can de-risk their part of it. Because they can finally say, okay, they said if it goes 150 miles an hour, we're good. Right?
Right.
And if you say it needs to go 150 miles an hour nonstop for 6 years. That's the moment when we'll give you substantial completion. That's a different story.
For sure.
And so people need to understand that. So that's been, part of those learnings go into early scoping and clear definitions. I think is what I would advocate for.
So you're now December, you're kind of 5-6 months into operating. Any other kind of lessons learned or words of wisdom to others in terms of?
My final kind of thing is on the same theme as these things never go as fast as you think they will. Whether it's procurement, on-site construction, commissioning, performance runs of the equipment, any of that stuff. But really, and we should know better because we've built a lot of facilities that have a lot of moving parts, and it always takes us longer to get them from start to optimally running at their full output in a nice, stable manner. And as business owners and developers, you need to bake that stuff into the model. You can't just say, oh, we're going to commission it on this day, and the very next day we're going to get 100% performance, and it's never going to stop. That's just not reality. So you need this, I would say, the more complicated the facility, the longer that ramp needs to be. You can start at 50% or start at 60%, but give yourself, months and months to pull out all the skeletons from the closet, because a lot of these systems are new to your operators. We've been operating a variety of different equipment, and there's maybe the membranes and the PSA are the only thing that's new for us there. We operate a number of compressors, we operate a number of heat exchangers, we operate a number of glycol chillers. So lots of the equipment is pretty familiar to us. But getting the system to work, homogeneously as one, and I always use the analogy of a symphony. Right. You're the conductor, and you got to bring all of these experts together, and your job is to make perfect, beautiful music, and it doesn't happen without practice, right? Someone's not going to get their note right. Someone's going to hang on too long. Someone's going to come in early. It takes a lot of time and a lot of knowledge to get that system to work the way it really should. And you're just going to find nuisance trips, and you're going to find problems that you just didn't think about.
That's right.
Oh, it got cold. We forgot to heat trace that one line. Whoops. Plants down.
So part of the lesson is kind of part of the financial modeling should contemplate in those early 6-8 months. An output factor that's much lower than
what the ultimate thing is. I mean, you got to push on your ops team to get there, of course.
Sure.
But I mean, the reality is that they can't know everything until they turn it on. And they can't know that, the valve opened 3 milliseconds too soon.
Right.
That's just a thing you're going to learn, and you're going to go back and find it. You can't know that you forgot to heat trace that thing until it freezes. And if you start in July, you might not know until December or January.
That's so true. Yeah.
And then some of those problems can become harder to solve, right?
Yeah.
So, give yourself some time.
You're hinting at like you're in that phase right now where you're.
Yeah, I would say we're just kind of getting out of that
Okay,
phase.
cool. Yeah.
Finally, I would say after 5 months, we think we've found most of the nuisance problems.
Okay. Yeah.
And now we're into, we're testing the assumptions on how long some of the consumables will last.
Oh, okay. Yeah.
Hey, we've got, media in the vessels. We said at this level of, at this gas quality, that's going to last for 6 months.
Right.
How's it performing?
Yeah.
Okay. We got 5 months.
Yeah.
We're checking it. Looks like it's going to, last, but because we weren't running at full capacity, now you got to kind of extrapolate when that will be. So now we're getting into that phase of kind of monitoring the performance and the longevity. Are you getting life out of your oil filters? How long are things lasting that you're consuming?
Yeah, yeah. Cool.
So that's
awesome.
More stable running things, but it's a good place to be.
And so as you kind of get to that more stable place on this big project, are you thinking and planning and dreaming about what's next at Walker?
Yeah, I mean, for Walker, I feel like this will be the last of the landfill gas utilization projects because it does kind of take us through the full curve of the gas from both landfills.
Yeah, yeah.
What I'm thinking about is what can I do with all the heat? We have heat from the compressors that we use to send gas to General Motors. We have heat from both of the 1 megawatt engines that produce electricity.
Yeah.
We have heat from all the compression and all the operations at the RNG facility, and we're still burning gas. We still flare gas, and so we have a lot of waste heat out there.
Okay.
And so we're thinking, how do we, utilize that? So I would say that's kind of it at the Walker campus here in Niagara. But more broadly for Walker, we are looking at other opportunities, other landfills that we operate.
Right.
As you know, we're getting to the end of a lot of the FIT and the RESOP contracts. They're going to expire here in the next 5 years. And so the question is, will the province reopen those contracts? Will the pricing structure not be a race to the bottom? Which, if it is, might incent developers to do something different with their landfill gas instead of just maybe pouring money into electrical generating assets. Maybe they'll do something else. So we look at some of those projects and think, hey, RNG could
at least you have a viable option technically and commercially that you didn't have in 2009, 10, 11 when the
exactly right. Yeah. And now we've got some operating experience, and so we feel like most more mature developers do, we might be able to have a better look and really understand the risk. And so when we look at projects that are on the cusp, you might not convince yourself to go do them, like you said early on. You might say, actually, that is not going to make the mark, because there's just this is too risky, or we don't know that.
You know too much.
But you do know too much. But then the corollary is that you can say, I feel confident that assumption is the right number, and that works in the model. So,
cool.
You got to take some wins out of your experience, and not all losses.
And stepping back a bit more broadly, I mean, you're a big contributor to the space. You're also contributing your time. You're newly re-elected, right? Or you're on the second half of your term with the CBA, the Canadian Biogas Association.
Yeah, I've been involved with the Canadian Biogas Association for a number of years.
Yeah.
I think I've been re-elected 3 times.
Yeah. Cool.
I was the co-chair a couple of years ago.
Okay.
So yeah, I mean, it's a great organization, and it's really the voice of the industry.
Yeah.
Early on, it was the voice for FIT contracts for small biogas on farm. Folks that knew they had something but didn't really know what to do with it.
Yeah.
And now they're advocating in that space for RNG production. Obviously, it's the shiny object right now, and I think as we think about hydrogen, I've always said that I think the RNG space will help de-risk the hydrogen transition. We'll learn how to write contracts. We'll learn how to develop pro formas. We'll understand equipment performance, how to stay away from new entrants into the market that maybe don't have this depth of experience that you might want. And then we'll learn how to build out off-taking capacity. What are the drivers for the market? How will legislation respond? What's the framework? So I think hydrogen is going to be a net beneficiary of all the work that folks like you and I are doing in the RNG space.
Yeah, I've never thought of it that way, but that is a very helpful Because sometimes I think about, okay, yeah, RNG for the future. At some point, we're going to reach, kind of capacity because there's only so many organics to go around.
Yep.
But that's only one part of it. You're right. It's setting the tone and setting a framework and a common industry understanding for, something that may have less supply constraints, which is hydrogen. I think we have a bigger upside there. But yeah, RNG can add a lot of value. That's cool. That's a cool way to think of it. Well, Graham, this was a lot of fun. There was things along the way that I had heard from you before but forgot, and other things I didn't know. And so thank you for agreeing to do this, and thank you for showing up this time.
Yeah, well, thank you for giving me a second chance to show up.
This is good. And are you on LinkedIn? Like if our listeners want to get a hold of you?
Yeah, absolutely. My LinkedIn profile, you can search through Walker, or you can just search Graham Guest, and you'll get to me either way.
Guest with a T.
Guest with a T.
Yeah, I love it. Good. And to our listeners, thanks for tuning in. This is another episode of Energy Radio. Great to talk about local projects with somebody local and a part of a local organization that's just leading the energy transition, doing it in a sustainable way. Thanks.